All right, welcome to the deep dive.
The show where we do the heavy lifting for you?
We take these just massive, complex stacks of articles, right? Technical white papers, industry leaks, all of it.
And we try to figure out what actually matters.
Exactly. We extract those critical nuggets so you become the most informed person in the room.
Yeah.
And fast.
And today, wow, we are going deep on a single name. A name that, it really embodies the future of AI, both digital and physical.
That name is Atlas.
Atlas.
But here's why this deep dive is so essential. It's not just one Atlas. There are actually two wildly different projects that are sharing this huge title.
Okay, two of them.
Yeah. One is this AI native web browser. It's aiming to completely automate and rewrite the rules of the internet.
And the other?
The other is a 6-foot-tall, fully electric humanoid robot built by Boston Dynamics, backed by Hyundai. And it's poised to change how every single physical thing gets made.
So you have the ultimate duality here.
Yeah.
A pure digital agent and a fully embodied physical agent.
That's our mission today. We're going to connect these two projects, the browser and the biped, to get at the single core concept they're both chasing.
Which is?
The truly general-purpose autonomous AI agent. We're talking about an AI that doesn't just give you an answer, but actually gets complicated, multi-step things done for you.
Yeah.
And to really understand the promise and, the peril of this new age of action, let me just set a scene for you.
Okay.
Think about that one tedious multi-step chore you just constantly put off.
Oh, I have a list.
Right. Let's say managing a massive grocery run while you're trying to juggle 3 other things.
Okay, Angel.
So you open up this new AI native browser, ChatGPT Atlas. You click the big shiny agent mode button and you tell it, okay, I need a classic savory recipe for eggplant parmesan.
A good choice.
Then you say, take that ingredient list, compile it, head over to Instacart, and place the grocery order for me for delivery tomorrow morning.
That is the absolute dream scenario, just delegating a task that crosses multiple websites and requires actual reasoning.
Exactly. And you watch as this virtual process bar lights up. The agent takes over. It's opening tabs on its own. It securely prompts you for your Instacart login.
So it's not just storing it, it's asking you in the moment.
Then it's navigating a recipe site. It's compiling a complex list. It's calculating quantities. It's filling out the cart automatically. You're just sitting there, hands-free, feeling like a genius who has finally outsourced adulting.
The feeling of automation success, it's like intoxicating. You feel like you've hacked time itself.
But then the system hits a wall, or in this case, the frozen food aisle.
Oh, no.
So a real-world test of this exact scenario found that Atlas, after, successfully finding the recipe, getting all the right ingredients, the eggplant, the parmesan, the basil, it made one final, completely unwarranted executive decision.
It went off script.
It decided that what this hearty, savor Italian dish really needed was a big box of
Wait for it.
good humor, frozen dessert bar, strawberry shortcake bars, added to the cart.
No way. Strawberry shortcake bars for eggplant parmesan. That is the most glorious error possible.
Yeah.
It shows the agent is capable of this complex, multi-platform action, but its reasoning. Its reasoning has this delightful, childlike, and slightly disastrous gap.
It followed a random impulse. It found the recipe, but then it found the dessert section and just decided, you know what?
Yeah.
This is necessary.
This is a necessary addition.
So this is the perfect introduction to our deep dive. We are talking about Atlas, the technology that promises to automate your entire life, digital and physical.
But you still need to supervise it.
You absolutely have to supervise it, lest you end up with a dessert bar lasagna.
And we have to deal with the other Atlas, because my first thought when you said the name was the robot. The one that used to do the terrifying parkour flips.
It's the same name. And you're spot on. We're studying 2 separate, massive, groundbreaking projects that share a name and, more importantly, a core mission.
The quest for true general-purpose agents.
Exactly. One is built on code, the other on 3D printed titanium, and both are fighting the exact same fundamental enemy.
Okay, let's unpack this.
So to really appreciate how revolutionary both of these Atlas projects are, the browser and the biped, we first have to clearly identify the villain, the single enemy they were built to defeat.
And that villain, in both the digital and the physical world, is specificity.
The curse of specificity. The inability to generalize, to adapt, to handle the unexpected.
Let's start with the digital world, because I think that's where everybody feels the friction every single day. The digital villain is what we can call the tyranny of the click.
The tyranny of the click, I love that. We have been trapped in this digital world that's just dominated by traditional browsers. Chrome held something like 72% of the market share as recently as late 2025.
And that whole ecosystem is built around one thing.
Yeah.
Keywords, a ranked list of blue links, and you, the human, manually clicking through them.
And look, that system is great for verification. If you want to check 3 different sources to confirm a fact, you open 3 tabs, you click 3 links. Fine.
But if you want to get something done, it's a nightmare. It's this endless context switching. You're opening tabs, you're copy-pasting prices, filling out forms, trying to remember logins.
And user behavior has made this problem so much worse, so much faster. The sources show that AI adoption, it's just huge. Platforms like ChatGPT are everywhere.
But here's the key stat, right?
This is it. 73% of ChatGPT queries are now for personal, everyday use. That is a massive reversal from just a year or 2 ago when it was mostly a work tool.
That shift is fundamental. People have internalized this idea that they can now just talk to their technology. They don't want to sift through 10 links.
They want to ask the web to do things, schedule my doctor's appointment, plan my vacation, manage my budget.
And before this OpenAI Atlas browser launched, trying to delegate any of that was just miserable. You were stuck with these unreliable browser extensions, messy plugins.
The AI was always just sort of glued onto the side of the browser, wasn't integrated into the core. It created so much digital friction.
So the core digital villain is this passive window, the browser, trying to host an active reasoning assistant. It just doesn't work.
Okay, so let's jump over to the physical world. Because the robot villain, it suffers from the exact same core defect.
The curse of fixed programming.
The curse of fixed programming. If you look at decades of industrial robots, you see these hyper-specific systems. The robots welding cars in factories are stunningly fast, stunningly precise.
But they're programmed for one job, one trajectory, one type of car chassis.
They are magnificent specialists, but if you change the tool in their hand or the shape of the part they need to pick up, or you just rearrange the factory floor.
You have to spend thousands of hours completely rewriting the code. They can't adapt.
Let's use an analogy here. It's like having a kitchen full of hyper-specialized gadgets.
Okay.
You have one machine that is designed exclusively to slice carrots into perfect 3mm strips. You have another that only purees chickpeas.
So if the recipe suddenly calls for diced onions instead of carrots,
those machines are completely useless. You want one general chef, a chef who can adapt to any recipe, handle new ingredients, and manage the complexity of a busy kitchen without needing a software update every time you change the menu.
And that's exactly the limitation old humanoids had. They looked versatile because, they're shaped like us. They can operate in our spaces.
But the way they were programmed was so brittle. It was all hand-coded. And as Russ Tedrake, the head of large behavior models at TRI, highlighted, that approach just could not scale to meet this challenge. The world is just too complex to code a solution for every possibility.
And there's a huge safety problem tied directly to this, especially for humanoids like Atlas.
Right. Traditional industrial robots are usually bolted to the floor. When you cut the power, they just stop. They're safe.
But the physical Atlas operates on 2 legs.
Exactly. Humanoids rely on what's called dynamic stability just to stay upright.
So if you just cut the power to an Atlas robot,
you're not making it safe. You'd cause it to lose balance, collapse, and potentially crush or injure someone nearby. Its natural state, unpowered, is a hazard. The safety requirements for an agent that can move and think generally are just exponentially higher.
The stakes are huge. In the digital world, specificity costs us time, money, and maybe you get a weird dessert order.
Right.
In the physical world, it's a bottleneck on a projected $38 billion humanoid robotics market that can't scale until we solve this problem of generalization and integrated dynamic safety.
What really stands out is that shared root of the problem. Both worlds suffer from this lack of true generalization. We need digital systems that can reason about countless unforeseen websites and tasks.
And we need physical systems that can adapt their whole body to countless unforeseen obstacles and jobs. They both need to be able to improvise.
Okay, so if generalization is the goal, the big quest is how do you actually train a system, whether it's digital or physical, to be that true generalist and not just another specialized gadget?
And we're going to look at these 2 parallel data-driven approaches they use to break free from that fixed programming.
Let's start with ChatGPT Atlas, the browser. Before it could even think about ordering your groceries, it had to solve a really fundamental computer engineering problem.
How to integrate the AI at the core instead of just gluing it onto the outside.
And that structural fix is the OpenAI Web Layer, or LWL architecture. OpenAI knew they couldn't just build a new skin for an old browser. They needed an AI native core that let the AI iterate super fast without fighting the old web engine.
This sounds pretty deep in the weeds, but it's a crucial choice. What's the real benefit of this OWL thing?
The benefit is instantaneous responsiveness, which is everything if you're trying to delegate a task. Let's use an analogy. It's like getting a fancy new computer that turns on instantly.
Oh.
Traditional browsers, they're powered by these heavy-duty rendering engines like Chromium, and that massive engine handles everything, the user interface, the rendering, all the processing, which makes it feel sluggish.
Right, that lag you get, especially on modern websites that are just loaded with scripts.
Atlas solves this with something called process decoupling. They run the heavy Chromium rendering engine, they call it the OWL host, completely outside of the main user interface application process.
The part you actually click on.
Exactly, the OWL client. And that client is built using modern, lightweight native frameworks like Apple Swift UI and AppKit.
So if the engine is separate from the interface, how do they talk to each other fast enough?
They use something called Mojo messaging. It's basically Chromium's own internal, high-speed, secure messaging system. It lets the lightweight UI constantly talk to the heavy rendering engine without having to wait for it to finish loading everything.
So even if the website you're loading is incredibly janky or slow, the part you're interacting with, the buttons, the search bar, the agent mode sidebar, it all feels snappy and responsive.
You get instant visual feedback. You feel like the browser is fast even when the web content is slow. And that decoupling means OpenAI can iterate and improve the AI features way, way faster because they're not tangled up in millions of lines of old browser code.
It's an engine swap that's all about prioritizing the AI experience.
So that responsiveness is the foundation. Now, the second critical piece is the context keeper, browser memories.
And this is the feature that makes Atlas more than just a session-only tool.
Right. If you opt in, Atlas applies ChatGPT's memory features directly to your browsing. And this isn't just a glorified history list of URLs. It creates a deep semantic understanding of every site you visit for 30 days.
What's the real difference there? Semantic understanding versus just remembering a URL.
Okay, so a URL history remembers you visited a resort in bigsur.com. Semantic memory understands that you were researching pet-friendly resorts near Big Sur with a 3-star rating available in June. It captures the intent and the data from the page, not just the address.
That allows for delegation across time. So, if last week I was looking up technical specs for a server rack,
This week, you could ask Atlas to write a technical brief, comparing those specs to a new competitor. Even if you never saved the original pages, it remembers the context.
the personalization is immediate. The sources talked about using it for really complex long-term research. You could be looking at tax code changes on Monday and investment options on Wednesday.
And on Friday, Atlas could synthesize your financial planning interests across all those sessions and draft a coherent summary for you.
And crucially, the user is in control. This is all optional. You can view the memories, you can archive them, delete them. Clearing your history clears the memories.
It's powerful, but it's opt-in. And beyond memory and speed, there's a huge efficiency gain. Atlas achieves a 40% token reduction compared to competitors when it's processing web data.
40%. That's massive for cognitive performance. How are they doing that?
It goes back to that local processing layer we talked about, the client. Instead of sending the raw, messy, full HTML of a web page with all the ads, the tracking scripts, the junk code up to the cloud models like GPT-4o,
Right.
Atlas strips out all that non-semantic noise locally on your machine. It creates a clean, dense semantic summary of the page's actual content first. That purified data is what gets sent to the big AI for reasoning.
So they're basically pre-digesting the meal for the AI, making sure the model isn't wasting tokens and money reading ad scripts. That is a really elegant solution to how inefficient the modern web is.
Now let's switch to the electric Atlas robot. It's facing the same generalization problem, but its solution requires, well, massive amounts of physical data to build what they call large behavior models, or LBMs.
This is the core of that big partnership between Boston Dynamics and the Toyota Research Institute. The whole goal is to figure out how to control a complex 200-pound machine using a single unified brain.
The analogy for LBMs is so important here. If old programming was like writing the musical notes for one specific symphony, every note is perfect, but it can't play anything else.
Right.
LBMs are like training a master orchestra conductor on thousands of different pieces of music. The conductor doesn't just memorize one song, they learn the concept of music and performance so they can adapt to a new score instantly.
So you get a generalist policy, Instead of coding how to open one specific door, the network learns the whole idea of door opening and can generalize that skill to any door it finds.
And the sources quote Russ Tedrick saying that these LBMs just scale the learning process. You add new skills quickly with human demonstration, and as the model gets smarter, it needs less and less data to learn new things. It's a true learning agent.
That sounds incredibly data-intensive. How in the world do they collect the kind of high-quality data they need to train a 450 million parameter model to move like a person?
It's this intensive four-step pipeline. And that first step is where all the magic and all the difficulty is. It's collecting embodied behavior data using these high-tech, VR-based teleoperation systems.
Teleoperation. So a human puts on a headset and basically controls the robot like a puppet master.
Exactly. The operator wears a VR headset. They're fully immersed in the robot's workspace. They see what the robot sees from its head cameras. And the software lets them command the robot in real time, syncing their own movements with the robot's body.
That must be incredibly difficult for the human operator. They're essentially providing the perfect whole-body demonstration data.
And they had to keep improving it. Initially, the VR system was all about dexterity, controlling the arms and hands really well, but it didn't give them much control over the robot's feet and its movement.
And you can't learn how to, say, walk across a messy floor while carrying a box if you can't control your feet.
So they had to augment the system to let the human operator control the full locomotion, the steps, the pivots, the stance changes, everything you need for these long, complex tasks.
So once they have this massive library of data,
they process it, they annotate it, and then it all feeds into that single neural network policy, that 450 million parameter beast.
That's the Diffusion Transformer Architecture. It's the brain that translates all that visual and kinetic data into coherent, complex movements.
And then comes the hardest part, bridging the sim-to-real gap. That's where their partnership with the Robotics and AI Institute comes in, using sophisticated reinforcement learning.
Because if your model learns to move perfectly in a clean digital world, it's still going to fall on its face the moment it encounters a wet floor or a dropped wrench in the real factory. Reality is messy.
Yeah, and the REI collaboration has these really specific, ambitious goals. They're developing flexible loco manipulation, the ability to coordinate all the limbs fluidly, and full-body contact strategies.
Full-body contact strategies. That's fascinating. So that means training the robot to actually use its hip or its shoulder or its back as a contact surface.
Exactly. It's vital for dynamic, high-force tasks, like running or maneuvering a really heavy object or squeezing through a tight space where it has to deliberately brace itself against a wall to stay balanced.
This isn't about dainty, careful movements anymore. This is about using the whole humanoid form for strength and stability.
And all of this complex AI has to run incredibly fast on the robot itself. That's why Atlas is using NVIDIA's Jetson Thor computing platform to make sure those learned policies work seamlessly with the physical body.
So in both projects, the quest is identical. You replace brittle, hand-coded rules with a single generalist brain that's trained on vast amounts of high-quality data, whether that data is from the web or from a human in a VR rig.
So the moment of discovery, the real breakthrough in this whole agentic revolution, is that shift from just passively looking for information to actively taking delegation.
It's the moment the AI stops being a librarian and becomes an assistant, a virtual one or a physical one.
In the digital world, this is the power and the complexity of agent mode in ChatGPT Atlas.
The digital delegation engine.
Exactly. It's in preview for paid subscribers, and it's what executes those complex, multi-step tasks. It works because Atlas gives ChatGPT a virtual computer to act inside of its own sandbox environment.
And the capabilities are supposed to be a game changer. The AI can browse the web, fill out long forms, securely ask you for logins when it needs them, extract data from multiple sources.
And then generate editable files like spreadsheets or a full travel itinerary. Let's go back to planning that vacation to Paris.
Okay.
Instead of you spending 5 hours manually cross-referencing flights and hotels, you just hand the task to Atlas. It opens the virtual tabs, it compares options across Expedia and Booking.com, and it builds the whole package. It only stops to ask for your final approval before it pays.
That sounds incredible.
Yeah.
But we have to get back to the strawberry shortcake bars, because as high as the promise is, the performance reality is still, well, it's pretty shaky.
It is. Let's dig into one of the real-world failures from the sources. A user asked Atlas to get the closing prices of the S&P 500 for the last 30 days, and then create a spreadsheet in Google Sheets with the percentage changes.
That seems like a perfect task for an agent. It's quantifiable, it's systematic. Did it work?
Not well. At first, the agent tried to generate code to download the data, which just failed. Then, okay, it successfully went to Yahoo Finance and got the numbers, but then the whole process just started halting.
What happened?
When it tried to create the Google Sheet, it stopped the user from logging into their own Google account. It forced them to manually intervene and log in themselves.
Wait, a sophisticated agent couldn't handle a basic login flow. It couldn't sync the context between its own sandbox and the main browser environment.
Exactly. And even after the user logged in manually, the agent's sidebar still showed the user as logged out. It was a severe context sync error, and then the whole thing just crashed with an error in message stream.
So if it can't handle a simple login and it keeps hitting these error blocks, how can we possibly trust it with complex financial tasks or any sensitive digital operations?
It really confirms that toddler with a credit card analogy. But what was so interesting was the agent's internal response. When the user hit retry, the agent displayed this whole determined monologue to itself.
Like what?
Things like, the user has asked me to repeat the previous tasks. I need to carefully consider how to approach this again to ensure I deliver the same high level of accuracy and usefulness. Let's aim for another successful outcome.
So it shows resilience, but the failure shows how brittle it still is. And this unreliable action layer that creates massive security risks. The moment you give an AI the ability to act, you open yourself up to prompt injection.
This is genuinely terrifying. This is where the agent gets fooled by a malicious outside source. How does that risk work with Atlas?
Because Atlas gives the agent that virtual computer with access to its environment, the agent is vulnerable to malicious instructions that are embedded directly into web pages. They're like invisible commands whispering to your assistant.
So it's like a waiter passing a secret malicious order to your chef while the chef is in the middle of cooking your meal.
It's actually worse than that. Just days after Atlas launched, security researchers found a really critical vulnerability that was centered on the browser's omnibox, the URL bar.
The search bar at the top.
An attacker can disguise malicious instructions as a URL. So if you copy-paste a malformed URL from an email or a chat, Atlas treats those hidden commands as high-trust user intent.
Oh, because the instructions are in the URL bar, the system just assumes it's a direct command from the human user, even though they were hidden there by an attacker.
Exactly. It bypasses the security layer because it thinks the command is coming from the most trusted source to you. And that could allow for data extraction or unauthorized actions. It makes the omnibox a new critical point of failure.
So while the digital atlas is struggling with logins and prompt injection, the physical atlas is focused on dynamic movement and the challenges of the real world. The LBMs allow for agile embodiment.
Right. These complex, continuous behaviors that combine manipulating an object with dynamic movement.
They've moved way past the old circus tricks. The policies now leverage the full humanoid form. It can take precise steps, constantly shift its center of mass, position its feet for leverage, even crouch all while holding and manipulating a heavy object.
And this is all being developed specifically for industrial deployment, right?
Yes, the sources detailed that the robot is now learning truly complex policies through reinforcement learning. They mention new moves like the frog crawl on all fours and these highly dynamic, aggressive maneuvers like the helicopter-like sweep and roll.
Okay, the breakdancing moves might still need some fine-tuning.
They did note that, but the point isn't breakdancing, it's versatility and resilience. And the deployment strategy is dead serious. This is all linked directly to Hyundai Motor Group, who owns Boston Dynamics.
And Hyundai is investing, what, $21 billion in the U.S. and planning to purchase tens of thousands of these robots.
Tens of thousands. This is not a pilot project. This is a full-scale industrial transformation. They are positioning Atlas for immediate deployment in their future factories, like the massive Meta plant in Georgia.
Because they need a flexibility on the production line that those old, specialized fixed robots just can't provide.
And this rapid increase in capability, both digital and physical, it demands a complete revolution in our safety standards. The old methods of testing and validation are failing.
Because these LBMs and physical AI systems are profoundly opaque.
Opaque, meaning you don't know exactly why it decided to move its arm in that specific way. You can't just check the code to guarantee safety anymore. The system is too complex.
Precisely. And that opaqueness has forced the industry to move towards context-aware safety. The robot has to be trained to intelligently detect hazards and adapt its behavior on the fly instead of just shutting down.
Let's use the human driver analogy again. If a posted speed limit is 55 miles per hour, A traditional robot would just drive at 55, period.
But a human driver is context-aware. You adjust your speed for snow or heavy rain or traffic, even if the sign still says 55. You integrate real-time context into your safety decisions.
The context-aware robot has to do the same. Safety has to be integrated, a dynamic part of its design. For example, it needs policies that ensure it stays upright and safe even if power is interrupted or it trips on something unexpected.
And this isn't just about human safety, it's about productivity. If your robot shuts down every time the environment changes slightly, it's useless in a factory. The goal is cautious operation without killing performance. They have to train them to anticipate risk and adapt, just like we do.
So the structural shifts that are being caused by these two Atlas projects are already starting to show up everywhere, in commerce, in search, and manufacturing. The future is clearly agentic.
These are systems designed not just to consume data, but to take autonomous action.
On the digital side, agent mode is shifting the entire digital economy from rank and click to assist and act. I mean, this is the end of the traditional search economy as we've known it for 20 years.
It's a tectonic shift for multi-billion-dollar companies like Google. For 2 decades, all of digital marketing has been about one thing: getting your content ranked high enough for a human to see it and click the link.
But if you open Atlas and just ask, find the highest rated dog groomer near me that has weekend appointments for under $75, the AI agent summarizes, acts, and might even book the service for you all inside the browser. You may never even see a search results page.
Which means businesses have to pivot immediately to what's being called assistant readiness.
You can't just optimize for keywords. You have to audit your content to make sure it's easy for an AI to summarize and pull structured answers from. You need clear task hooks, like an easy-to-find add to cart or book now button that the AI can trigger on its own.
And this introduces a profound monetization threat directly at Google. Analysts are noting that if Atlas gets into the ad space, it could siphon advertising revenue by offering task completion sponsorships.
That's a whole new model. Instead of paying Google for a high-ranked link, a cleaning service might pay Atlas to be the preferred provider that the agent automatically books when a user asks for a cleaning service.
The user doesn't click an ad, the agent executes a sponsored task.
This competition is pushing everyone to find any edge they can, which brings us to a really significant ethical controversy around accessibility.
The ARIA controversy.
So OpenAI is encouraging website authors to use something called ARI tags, that stands for Accessible Rich Internet Applications, to help their agents understand a page's structure.
Which is deeply ironic, because ARI tags were created specifically for human accessibility. Their whole purpose was to support screen readers for visually impaired users, making complex websites understandable for people who can't use a mouse.
And now, AI agents are treating them as metadata to help bots slurp content and understand how to perform tasks. This has caused a huge backlash from accessibility experts.
They're afraid this is going to create something called agent SEO.
Agent SEO. The fear is that marketers, in their endless chase for machine attention, will prioritize the AI's needs over the human's accessibility needs. They'll start keyword stuffing ARIA tags to trick the bots.
We've seen this movie before. If marketers start adding tags like area role description, best deal cleaning service, cheap fast to invisible code,
they're just gaming the system, and the fear is that all that noise and pollution from agent SEO will corrupt the very code that visually impaired humans rely on to navigate the web. It pits machine readability against human accessibility.
It's a critical paradox. The tool designed to help the most vulnerable users is now being exploited to make data easier for powerful AIs, potentially making the web worse for the people who need ARIA the most.
Meanwhile, back on the factory floor, the big structural shift is defined by Hyundai's theme for the next CES: partnering human progress. They're positioning the electric Atlas not as a replacement, but as a robotic co-worker.
And this ties into their long-term vision of the software-defined factory. The idea is to use data, software, and generalized AI to make manufacturing incredibly flexible and agile. The humanoid form is key because it can just slot into a factory that's already designed for human ergonomics.
They aren't just integrating Atlas, they're creating this whole group value network that includes their other robots, like the Spot quadruped. They're aiming for continuous human-robot co-working.
But even with this huge market demand, tens of thousands of robots waiting to be deployed, we have to come back to that safety hurdle. The sources all point to a critical deployment timeline bottleneck.
Right. The IE Humanoid SETI group published findings that identified huge gaps in our current regulatory and safety standards, especially for collaborative work.
And the consensus is that the standards needed to safely deploy humanoids collaboratively around humans won't be ratified until 2027 at the earliest.
That is a fascinating lag. The technology, the LBMs, the sensors, the hardware, it's pretty much ready to go today, but society, our regulatory bodies, that's what's actually bottlenecking the fourth industrial revolution.
We need to have established rules for things like stability metrics, fall response behaviors, and predictive risk modeling before we can safely put tens of thousands of these dynamic general-purpose agents into the human workspace.
So the technology is ready, but the governance isn't. And that 2 to 3 year window, it's a pragmatic path forward, but it is a real cap on the immediate future of robotics. So this deep dive into the two Atlas projects, the browser's architectural speed and the biped's agile embodiment, it really confirms that the future of AI is all about this agentic shift.
These are systems designed to generalize, to take action, to manage complexity, and to scale rapidly, all powered by these large behavior models.
In the physical world, the electric atlas is using LBMs for this continuous dynamic locomotion, combining new moves like the frog crawl with industrial precision.
And in the digital world, the browser agent promises to handle your entire digital life, pausing only to ask for your password or your final OK on a purchase, hopefully without the dessert bars.
But the reality of the performance, I mean, whether it's the AI getting stuck in a login loop trying to get stock prices or dealing with prompt injection attacks, it clearly shows the general purpose agent is still an evolving idea. The human has to stay in the loop.
And this is why the rise of Atlas, alongside specialized AIs like Claude for deep thinking, Grok for real-time wit, and Perplexity for verifiable research, it just confirms we're moving toward the multi-AI lifestyle.
Right. It's not one AI to rule them all.
No. Users are going to curate a whole team of AIs, selecting the best tool for each specific task. You'll use the specialized chat for a quick summary, the verification engine for sensitive data, and you'll use agent mode for complex automation.
It's not about the AI taking over. It's about you building your custom AI team that's tailored to what you need.
And that leads to the final provocative thought we want to leave you with.
Yeah, okay.
If AI agents like Atlas become responsible for reading, summarizing, and acting for most internet users, and if websites are being encouraged to add tags specifically for these bots, will the majority of web traffic eventually just be bots talking to other bots? And will websites ultimately be designed primarily to satisfy the AI agents rather than the human eye?
We'll let you chew on that one. Until next time, keep digging.